What is an auxiliary substance?
Chemical auxiliaries are substances like solvents, separation agents, or dispersing agents that are used in the course of a chemical synthesis but are not reagents because they are not incorporated into the chemical product.
What is a shell?
A way of classifying the orbitals in which electrons can reside based on their principal quantum number.
What makes strong acids and bases dangerous to work with in the laboratory?
Strong acids, like nitric acid, are strong oxidizing agents and can cause severe burns on your skin. Strong bases, like sodium hydroxide, can also cause burns as well as nerve damage. Strong acids and bases destroy your cells by reacting with the membranes, proteins, and other components that make up your cells. They are also dangerous to your eyes and can permanently damage your vision.
What is gene therapy?
Gene therapy is a method of medical treatment that tries to correct defective or disease-causing genes. There are a few ways that this may be attempted, all of which are centered around getting a normal, functional copy of the gene inserted into the genome. Some methods involve repairing the mutated gene, while others involve just adding a working copy of the gene into a non-specific location in the genome.
What is a buffer?
A solution that tends to resist changes in pH upon addition of an acid or base.
What is a metalloid?
An element, compound, or alloy that has metallic and non-metallic properties.
How do you use pH paper?
Another way of measuring the pH of a solution is with pH paper. This is a paper strip that contains a chemical indicator that changes color depending on the pH of a solution. And it can be capable of determining a very wide range of pH values. To properly use pH paper, it should not be dipped directly into the solution, but rather a drop of the solution should be placed on the pH paper. It can then be held next to a gradient color scale to obtain a pH value. Since this relies on visible color changes, it isn't the most accurate method of determining pH. But it can be a useful tool in the lab for getting a quick estimate of the pH of a solution.
What packing arrangements are possible for a crystal lattice?
There are three basic packing arrangements, which we can describe by again imagining a tiny box. If we place an atom at each of the 8 vertices of this box, the arrangement is referred to as simple cubic. If we take a simple cubic unit cell and add an atom to the center of each face, we have a face-centered cubic arrangement. If we instead add an atom to the center of the cube, it's called a body-centered cubic unit cell. There are more possibilities, but these three simple ones described here cover a lot of the crystals that chemists encounter.
What is the collision frequency?
Average number of collision events per second.
What is a Kelvin?
Standard temperature scale in which the triple point of water is defined at 273.16 Kelvin.
Why did Paul J. Crutzen, the Netherlands, Mario J. Molina, Mexico/United States, and F. Sherwood Rowland, United States, win the Nobel Prize for Chemistry?
For their work in atmospheric chemistry, particularly concerning the formation and decomposition of ozone. Each of these researchers made important contributions toward understanding how atmospheric ozone is depleted through atmospheric reactions. Importantly, each demonstrated ways in which pollution from humans was responsible for depleting the ozone layer. And they did this by learning how atmospheric pollutants caused the breakdown of ozone. This information will hopefully continue to help us protect the ozone layer and the stability of the Earth's climate.
What is calorimetry and what is it used for?
Calorimetry involves measuring the amount of energy released during a chemical reaction in the form of heat. This is accomplished using a device called a calorimeter. A calorimeter is a container inside which a chemical reaction can be carried out while thermally insulated from the surroundings. This can even be something as simple as a sealed styrofoam, or coffee cup with a thermometer inserted through the lid, though more sophisticated devices certainly do exist. The temperature change inside the calorimeter can be monitored to determine the amount of energy given off during the chemical reaction, which can then be used to determine the enthalpy change associated with the reaction.
What's in self-rising flour that makes it rise?
Baking powder and salt are added to flour to magically transform it into self-rising flour. Yeah, not so magical after all.
How do herbal medicines differ from modern medicine?
Modern pharmaceutical medicines usually contain only one active ingredient, or a few at most. The rest of the ingredients in a pill are there to aid in its delivery in one way or another. Herbal medicines, because they are made from plants that were once living, can contain many more chemicals, though only one may be the active ingredient in this case as well.
There are polymers in my shampoo and conditioner, too?
There are many ingredients in shampoos and conditioners are similar to most soaps, surfactants, etc., but cationic polymers play important roles in these products. One family of these polymers is named polyquaterniums, which is closer to a trade name than a technical chemistry name. The structure of one member of this family, polyquaternium 1, is shown below. All of these polymers contain positive charges, which allows them to form ionic bonds with hair strands. This prevents the polymers from being rinsed away with water. Once coated, your hair strands are now less likely to stick to adjacent strands and appear shinier.
What is PP, polypropylene?
If instead of substituting a chlorine atom we add a methyl group to each ethylene monomer, we get polypropylene. Recall from earlier that this introduces stereochemistry along the polymer. We've already mentioned that the arrangement of the methyl groups along the polymer chain can have large effects on the melting point and other physical properties. You can likely find polypropylene all over your house, from dishwasher-safe food containers to synthetic carpets, especially outdoor carpeting, and an increasing weight fraction of your car, including the bumper and the casing for the battery. It can also be made into ropes, which are quite strong and resistant to weather. So they are frequently used in fishing and farming. Polypropylene is also used for many medical applications because it is capable of withstanding the high temperatures required to sterilize.
How do pop rocks, candy work?
Pop rocks, is a carbonated candy like soda is a carbonated beverage. The fizzing that goes on in your mouth is due to carbon dioxide, CO2, bubbles escaping from the candy. To make this unique treat, the ingredients are heated, exposed to high pressures of carbon dioxide, and then cooled to trap the CO2 inside the candy.
How are soft drinks carbonated?
Soft drinks are carbonated using pressurized CO2 gas and a siphon that introduces the pressurized gas into the water or soda. The CO2 gas is forced into the liquid at a concentration beyond that which could exist under atmospheric conditions, and then the container is sealed, preventing it from being released. That's why if you leave a glass of soda sitting out, it will go flat, the CO2 escapes into the air.
Where are electron transfer reactions important?
Electron transfer reactions are important in many areas. In biological systems, processes like photosynthesis, nitrogen fixation, and aerobic respiration. The process your body uses to make energy using oxygen, all rely heavily on electron transfer reactions. Electron transfer reactions are also frequently used to obtain pure metals from ore. Electrochemical cells, see analytical chemistry, also rely on electron transfer reactions. The batteries that power your cellular phone and other devices use electron transfer reactions to do so.
What is bagasse?
After sugarcane stalks are crushed and pressed to remove their juice, the remaining plant matter is known as bagasse. After the water is removed, and bagasse can contain a lot of water. Bagasse is mostly composed of cellulose, hemicellulose, and lignin. Typically this material is burned by the sugar mills directly to generate heat for other processes running at the mill or electricity, which can also be used at the mill or sold back to the electric grid. Bagasse also finds its way into paper production. Recently bagasse has been targeted as a potential source of ethanol.
What is nuclear fission?
Nuclear fission is essentially the opposite of nuclear fusion. Here, a single nucleus divides into two smaller nuclei. In the case of heavy atoms, this is often accompanied by the release of heat. For example, the radioactive decay of uranium-235 can be used to generate the heat used to drive turbines to generate electricity in nuclear power plants. The use of nuclear fission to harness energy for use by humans is typically considered the much more viable choice, as opposed to nuclear fusion.
What are some different types of titrations?
We already considered the titration of a base by an acid. Certainly acids can also be titrated by bases. But there are also many other types of titrations, so let's look at just two more. Complexometric titrations. This type of titration involves using a titrant that forms a complex with the analyte. In this case, the species of unknown concentration is often a metal ion, and the indicator may be a dye molecule that forms a weak complex with the metal ions. The indicator ion complex is bound more weakly than the titrant ion complex, such that the titrant can displace the indicator from the metal ions. Thus, when the titrant has bound to a significant fraction of analyte molecules, the indicator molecules are displaced and the solution will change color. Redox titrations. A redox titration is a titration that involves the use of a reducing agent or an oxidizing agent to determine the concentration of the unknown species. In this case, the indicator can again be sensitive to the presence of excess titrant, giving a color change when the titrant becomes present in excess.
How does one determine the oxidation state of an organometallic complex?
There are a few ways to approach this problem, and, of course, every chemist thinks the way they use is the most correct. But let's look at what is hopefully the simplest way to think about this. We're going to only talk about complexes with metal carbon bonds and no other types of ligands. If you're curious enough to want to know how nitroxide binds a transition metal, chances are you have an inorganic chemistry textbook at home anyway. Okay, let's look at tetra, methyl, zirconium, which has no net charge. In this counting technique, all of the electrons in the metal carbon bonds are placed on the carbon atoms. So we get 4 methyl anions and 1 zirconium ion. Since this complex has no net charge, the zirconium center must balance out the net 4 negative charges from the methyl groups. Zirconium must be in the +4 oxidation state. Easy, right? One more example, K3Fe, Cn, 6 or potassium hexacyanoferrate. We again move the electrons in the metal carbon bonds to the carbon groups, making 6 cyanide ions, Cn, an iron ion, and 3 potassium ions. We have 6 negative charges, 6 Cn, and 3 positive charges, 3 K and ions. So to balance out the charges, the iron center must be in the +3 oxidation state. Zrme4 Me1 plus Zr4 plus K3Fe, Cn, 6 3K1 plus 6 Cn1 plus Fe3 plus. It's important to remember that when we count electrons in this way, we're doing only that counting. Don't get the idea that all of these metal carbon bonds are the same, or that they're all ionic bonds. This is just for electron bookkeeping.
How do scientists determine how far away a star is?
The answer to this question lies in the application of trigonometry. An astronomer can look at a star at a given point in time and then look at it several months later. after the Earth has moved a substantial distance in its orbit around the Sun. This allows the astronomer to view the star from two different angles. By comparing the images from the two different angles, it is possible to figure out how far away it is. If a star happens to be too far away, the first method described will not be accurate. But fortunately there is an alternative. If an astronomer measures the visible light spectrum of the star, it turns out that one can get a good idea of its actual brightness. By actual, we mean how bright the star is if you are right up close to it. This relationship isn't entirely straightforward and has only been established after looking at data from thousands of stars. Once the astronomer knows the actual brightness, its brightness can be compared by its apparent brightness as viewed from Earth to determine how far away it is.
How much energy is produced from a given amount of coal, oil, or gas?
One ton of coal can produce 6,182 kilowatt-hour of energy. 1 barrel of oil can produce 1,699 kilowatt-hour of energy. 1 cubic foot of gas can produce 0.3 kilowatt-hour of energy. How much does it cost to produce energy from gas, coal, solar energy, etc.? If 1 ton of coal costs $36, which gives an energy cost of $0.006 per kilowatt-hour, and 1 barrel of oil costs $70, which gives an energy cost of 5 cents per kilowatt-hour, and 1 cubic foot of gas costs $0.008, which gives an energy cost of 3 cents per kilowatt-hour, then a 4 kilowatt solar panel system providing energy for an average ranch-style home and costing $25,000 and lasting about 20 years would provide about 120,000 kilowatt-hour for the life of the system, depending on climate, and cost about 21 cents per kilowatt-hour. You can see that solar power is still currently more expensive than other fuel sources.
What is a solvent?
The major component of a solution.
How do solar cells work?
The sun gives off 1000 watts of energy per square meter of the Earth's surface, which, if we could harness all of it, is more than enough to fulfill all of the world's current electricity needs. It's not easy to do this, however, which is why we still rely primarily on other energy sources. A solar cell, or photovoltaic cell, harnesses energy from photons of sunlight by having them excite electrons in a material. An electric field is established within the solar cell using a process called doping. And this makes it so that the excited electrons can only flow in one direction. Thus, when sunlight strikes the solar cell, a current flows. And this is the basic principle on which solar cells operate to capture energy. The harnessed energy can either be used immediately or it can be stored for later use. Designing more efficient solar cells is a very active area of research. And you can expect their efficiency to continue to increase in coming years.
What are the benefits and challenges of using water as a solvent?
The advantages of using water as a solvent are numerous. Water is plentiful, environmentally benign, spans a wide range of temperatures while in the liquid phase, and cuts down on waste. Of course, if there weren't also some challenges to making it work, we would just be using it for every reaction. A primary challenge of using water is that many compounds are either unstable or insoluble in water. Additionally, many reactions that were developed in organic solvents do not proceed. Similarly, under aqueous conditions for a variety of reasons. So the majority of existing knowledge surrounding organic synthesis, most of which was developed under non-aqueous conditions, often cannot be directly applied to reactivity under aqueous conditions. Water can also be difficult to remove from reactions relative to many organic solvents due to its higher boiling point. Since the advent of green chemistry, the amount of research into aqueous synthesis has skyrocketed, and significant progress is being made every day toward the use of water for a growing number of synthetic applications.
What is a lone pair?
A pair of valence electrons that are localized on a single atom, i.e., not involved in bonding.
What is an oxidant?
An oxidizing agent, or a species that removes electrons from another species.
How do chemists name so many different hydrocarbons?
With a bunch of rules. Let's start with just straight chains of carbon atoms. Here we just need to define how many carbon atoms there are in the molecule. If the molecule doesn't have any double bonds, we use the suffix "ana". The prefix indicates how many carbon atoms there are. Most of these prefixes are based on Greek numbers, one is Latin, and a few are just weird. Collectively, these molecules are called alkanes.
What is polarity and how is it related to molecular structure?
Polarity is related to the symmetry of the arrangement of electron density in a molecule. Polar molecules are those which possess a net dipole moment. which means that the electron density is not symmetrically distributed in all directions. Nonpolar molecules have the electron density distributed in such a way that there is no net dipole moment. Typically, this doesn't mean that nonpolar molecules have their electron density distributed evenly over every part of the molecule, but rather that the dipole moments created by an unequal sharing of electrons in each individual bond cancel each other out, so that there is no net direction in which an asymmetry of electron density exists.
Why did John Warkup Cornforth, Australia, United Kingdom, win the Nobel Prize for Chemistry?
For his work on the stereochemistry of enzyme-catalyzed reactions, and Vladimir Prelog, Yugoslavia/Switzerland. For his research into the stereochemistry of organic molecules and reactions. Cornforth explored the stereochemistry of enzyme-catalyzed reactions by using isotopically labeled hydrogen atoms to study the geometry of their arrangement in the enzyme's active site. Prelog studied how the stereochemistry of organic molecules affected their reactivity, leading to important discoveries. He also explored the stereochemistry of enzyme-catalyzed reactions, observing how they reacted with simple organic molecules. Why did William N.
What is the valence shell electron pair repulsion model?
The valence shell electron pair repulsion model, V-spare, is used to predict the bonding geometry about a central atom based on a set of rules that predicts the repulsive forces between the electrons in chemical bonds and in lone pairs. In this model, two factors are used to predict the bonding geometry: the steric number and the number of lone pairs of non-bonding electrons. The steric number is defined as the number of atoms bonded to the central atom plus the number of lone pairs of non-bonding electrons. Based on these two numbers, the table below predicts the bonding geometry that will be observed about a central atom. It should be noted that this is just a predictive model, and it will not be correct 100% of the time.
What is a carbocation and what is a carbanion?
A carbocation is a positively charged compound in which a carbon atom takes on a significant fraction of the positive charge. The definition for a carbanion is probably easy to guess. Then it's a negatively charged compound in which a carbon atom bears a significant fraction of the negative charge.
What is thermoplastic?
A type of plastic that hardens when heated and then cooled.
Okay, last sweetener question. What is corn syrup?
Corn syrup is made from cornstarch either by heating up starch in an acidic water solution, or by adding an enzyme to break down the long starch molecules into simpler sugars. Chemically it is mostly maltose, which is a disaccharide, two glucose molecules stuck together, along with a small amount of larger chains of sugar molecules, oligosaccharides. The high fructose variety is made by treating regular corn syrup with a second enzyme that converts glucose into, you guessed it, fructose.
How can I suck an egg into a bottle?
Chemistry principles encountered in this experiment: combustion pressure, ideal gas laws, materials you'll need. Hard-boiled egg bottle or flask with an opening slightly smaller than the egg's diameter, paper. A sheet of computer paper or newspaper will do, matches the procedure. Note, this experiment involves fire and flammable materials, so adult supervision is a must. Peel the hard-boiled egg. Tear off a piece of paper that can easily fit into the bottle, and carefully light it on fire and drop it into the bottle. Quickly place the egg on top of the bottle, covering the opening. The flame will burn, heating the air inside the bottle. This causes the air to expand, and some of it will push past the egg to escape from the bottle. Recall from our discussion of the ideal gas law that, for a fixed number of particles and volume, the pressure inside the bottle should increase linearly with increases in temperature. The increased pressure is what pushes the air out. And you may even see the egg shake a little as the air escapes. Then the egg will come to rest, covering the opening. Eventually, the fire will burn up all of the paper, or all of the oxygen inside the bottle. Whichever comes first, and then the air in the bottle will begin to cool. As it cools, the volume it occupies will decrease, lowering the pressure inside the bottle relative to that outside the bottle. The higher pressure outside the bottle is what pushes the egg through the opening and into the bottle. You can get the egg back out by tilting the bottle upside down and blowing air into the bottle, and then allowing the egg to cover the opening before removing your mouth. Thus you can use the same principle regarding equilibration between high and low pressures to force the egg out.
Why don't oil and water mix, anyway?
The simplest way to answer this is with the phrase you probably learned in high school, like dissolves like. Water is a polar molecule, so it prefers to interact with other polar molecules. Oil, a hydrocarbon of some type, lacks polar groups and forms weak van der Waals interactions with other nonpolar molecules. This is only partially correct, and the actual situation is quite complicated. The major force at work here is the stability of the water phase due to the hydrogen bond interactions. When a molecule of a hydrocarbon is dissolved in water, some number of hydrogen bonds must be broken. This bond breaking costs energy. When oil and water don't mix, these hydrogen bonds outweigh the entropy gained by mixing the phases, so the water molecules stick together, and the oil remains separated.
What is an amplitude?
The height, or maximum displacement, of a wave.
What is magnetic permeability?
The magnetic permeability of a material describes the extent to which it is able to support a magnetic field inside itself. It describes the amount of magnetization that takes place in a material when an external magnetic field is applied. Materials with a high magnetic permeability are able to support a stronger magnetic field within themselves.
Why might a soft drink freeze when you open it?
Remember that the freezing point of a solution is decreased by having anything dissolved in it. When a soft drink is opened and CO2 rushes out, less CO2 is present in the solution, causing the freezing point of the solution to increase. So at a constant temperature, the increase in freezing point causes the soda to freeze. If you haven't seen this happen, you can try to make it happen by placing a soda in the freezer for a while. But be careful not to leave it in too long or it might explode.
What is an empirical formula?
The relative ratios of elements in a substance.
Why did Richard R. Ernst, Switzerland, win the Nobel Prize for Chemistry?
For his contributions to the development of the methodology of high-resolution nuclear magnetic resonance, NMR, spectroscopy. Nuclear magnetic resonance, NMR. Spectroscopy has proven to be a powerful tool for physical and synthetic chemists alike. It has been used to characterize the structures of simple organic complexes, complex biomolecules, and to dynamically track the progress of chemical reactions, among other applications. Ernst won the prize for his substantial contributions to increasing the sensitivity and resolution of NMR instruments. Ernst contributed to improving a wide variety of aspects of NMR spectroscopy, including both one and two-dimensional approaches. and he also proposed a method for obtaining NMR tomographic images, which was eventually realized.
What is black body radiation?
Electromagnetic radiation given off by a black body. At room temperature, most of this radiation is in the infrared. But at higher temperatures, visible light can be emitted.
Do chemists really study food chemistry?
Yes, they really do. There's even a scientific journal called Food Chemistry, published by Elsevier, dedicated to reporting new findings regarding the chemistry and biochemistry of food and raw food materials.
Why did Richard F. Heck, United States, Eiichi Negishi, Japan, and Akira Suzuki, Japan, win the Nobel Prize for Chemistry?
For palladium-catalyzed cross-couplings in organic synthesis. Heck, Negishi, and Suzuki shared this prize for their development of a class of reactions called palladium-catalyzed cross-couplings. These reactions are a powerful tool in organic synthesis, allowing chemists to form carbon-carbon bonds, which is generally not an easy task at all. The reaction is accomplished by having the carbon atoms first join to a common palladium center, from which point carbon-carbon bond formation can proceed.
Why does drinking alcohol make people loopy?
Alcohol, specifically ethanol, CH3CH2O, is a mild depressant that affects your central nervous system. The specific biological effects are pretty complicated. Some systems are enhanced by ethanol. Others are inhibited. This combination of effects is why drinking can relax your muscles but also make you more animated. It may seem that alcohol lowers your inhibitions, but some experiments suggest this is a psychological effect and not a chemical one.
What is a chemical bond?
A chemical bond is an attractive interaction that binds atoms together through a sharing of electron density. The simplest bonding arrangement involves just two electrons shared between nuclei such that each effectively has a stable octet of 8 valence electrons, or just 2 in the case of HH. When two atoms are sharing a total of 2 electrons between them, the atoms are referred to as singly bonded to each other. Bonds are what hold atoms together in molecules, and they are usually not easily broken. The arrangement of atoms in a molecule determines the identity of a chemical compound. The making or breaking of bonds is a chemical reaction, which converts one chemical compound into another.
Why did Lord Alexander R. Todd, United Kingdom, win the Nobel Prize for Chemistry?
For his work on nucleotides and nucleotide coenzymes. Todd laid the foundation for future research in biochemistry, genetics, and biology surrounding the structures and roles of nucleotides in living organisms. He established the chemical structures of nucleotides and established the, extremely important, role of phosphorylation in biochemical processes.
What is the temperature in outer space?
There is not actually a single uniform temperature for all of outer space, it tends to be warmer. At least in a relative sense, in areas that are closer to stars or planets. On average, though, the temperature is only about 3 Kelvin, which is about minus 270 degrees Celsius. It is extremely cold in outer space, so we humans would not last long floating around in the far reaches of space. Even if we could breathe there, which we can't.
What is a gamma radiation?
High-frequency electromagnetic radiation can be dangerous to living things.
What kind of fuel is used to power a spacecraft?
The Space Shuttle Endeavour, which made its final space voyage in September of 2012, used primarily hydrogen, oxygen, hydrazine, N2H4, monomethylhydrazine, CN2H6, and nitrogen tetroxide, N2O4, as fuels. As it took off for a space voyage, the spacecraft would carry 835 958 gallons of these fuels with a total weight of roughly 1.6 million pounds.
What is the current model for the atom?
The current model for the atom consists of negatively charged electrons orbiting a positively charged nucleus. The nucleus consists of neutrons and protons that are very tightly bound to each other by a strong force. Orbiting electrons behave something like a cloud surrounding the nucleus. And we can't be sure quite where they are at any given time. The electrons are also very lightweight compared to the nucleus, and they move much, much faster.
Why did Ernest Rutherford, United Kingdom, New Zealand, win the Nobel Prize for Chemistry?
for his investigations into the disintegration of the elements and the chemistry of radioactive substances. Rutherford's most famous experiment, the gold foil experiment, was actually done after he received the Nobel Prize. He was awarded the Nobel for discovering that there were multiple kinds of radioactivity. He named them alpha and beta rays. Why did later he added gamma rays to the list? And for proposing that radioactivity was a result of the atom actually breaking apart. Until Rutherford's work, chemists had assumed that atoms were indestructible.
What is a quantum?
A discrete amount of energy, electric charge, or another physical quantity.
What is a stable octet?
The term stable octet describes the fact that many atoms in molecules are most stable when the valence shell contains effectively 8 electrons. This counts both non-bonding electrons and electrons in chemical bonds between atoms. Molecules tend to be most stable when the valence shells of each atom in the molecule contain 8 electrons. In the Lewis structures for F2 and CH2O, see the previous question. We see that the fluorine, carbon, and oxygen atoms are each surrounded by 8 electrons. We get this total by adding both the non-bonding and bonding electrons. Since hydrogen atoms are in the first row and have just a single orbital in their valence shell, they only need 2 electrons, a single bond, to fulfill their analog of a stable octet.
What is the hardest material in your body?
Tooth enamel is the hardest material in your body. It's even harder than bone.
What causes smog?
Smog is caused by chemical reactions involving volatile organic chemicals and nitrogen oxides that take place in the presence of sunlight. These pollutants can come from a variety of sources. But in urban areas, a large quantity usually comes from motor vehicles. These are the reasons that smog often becomes a bigger problem when there is heavy traffic and lots of sunlight.
Why did John Warkup Cornforth, Australia, United Kingdom, win the Nobel Prize for Chemistry?
For his work on the stereochemistry of enzyme-catalyzed reactions, and Vladimir Prelog, Yugoslavia/Switzerland. For his research into the stereochemistry of organic molecules and reactions. Cornforth explored the stereochemistry of enzyme-catalyzed reactions by using isotopically labeled hydrogen atoms to study the geometry of their arrangement in the enzyme's active site. Prelog studied how the stereochemistry of organic molecules affected their reactivity, leading to important discoveries. He also explored the stereochemistry of enzyme-catalyzed reactions, observing how they reacted with simple organic molecules. Why did William N.
What is plasma?
Plasma, the fourth state of matter, is a gas where some amount of the particles have been ionized. As little as 1% ionization leads to very different properties for plasmas than gases, including increased conductivity, like lightning, and magnetization.
Why did Henri Moissac, France, win the Nobel Prize for Chemistry?
For the investigation and isolation of the element fluorine, and for electric furnace called after him. Moissac was the first to make fluorine gas, F2, which he did by passing an electric current through a solution of KHF2 in liquid HF. The second part of the committee's statement relates to his work on an electric arc furnace, which he designed to try to make synthetic diamonds.
What happens chemically that causes a hangover?
Hangovers are believed to be caused by the buildup of acetaldehyde. This aldehyde is formed from the oxidation of ethanol, which is of course the alcohol you drank in the first place. Acetaldehyde is an intermediate in your body's process for dealing with all that booze you drank last night. An enzyme, acetaldehyde dehydrogenase, further oxidizes acetaldehyde to acetic acid. Of course, there are a lot of other factors that might make you feel terrible the morning after a big night out. Your liver gets pretty taxed dealing with all of the toxins, which is why some people think that distilled alcohol, which removes heavier molecules in the alcoholic beverage, leads to less severe hangovers.
What makes something magnetic?
As we mentioned just briefly above, electrons have a property called a spin, or spin angular momentum, which can take on two possible values. This property, combined with the fact that electrons are charged particles, dictates that each electron has an associated magnetic moment, called the spin magnetic moment. In a macroscopic object, magnetism, or lack thereof, is determined by whether these spin magnetic moments are all aligned in the same direction. If all of the spin magnetic moments line up in the same orientation, the object will behave as a magnet. If the spin magnetic moments are oriented randomly, the object won't be magnetic. The trick is that only certain materials have the potential to exhibit magnetism. And we'll get to that next.
What is smog?
The word smog was originally derived from a combination of the words smoke and fog. And today it describes air pollution that, once in the atmosphere, reacts with sunlight to form additional pollutants. The main sources of this pollution are commonly motor vehicles, factories, power plants, and burning of fuels. The main chemical components of smog are ozone, nitric oxide, nitric dioxide, and volatile organic compounds. Smog is present in pretty much every large city around the world. It can be hazardous to human health and has been blamed for health problems and even deaths.
What is Le Chatelier's principle?
Le Chatelier's principle tells us how to predict the effect a change in conditions will have on a chemical equilibrium. It tells us that a system at equilibrium will shift to counteract changes that disturb the equilibrium. These could be changes in concentrations of chemical species, temperature, pressure, or other conditions. The most commonly discussed changes involve changes in concentration of chemical species. So we'll just focus on those here. For this equilibrium, A and B, D, C and D, if we decrease the concentration of A, some C and D will react to replenish the A that is depleted, so the concentrations of C and D will decrease. As species A is replenished, more B will be created as well. So the net effect is that decreasing the concentration of A will also decrease the concentrations of C and D, and at the same time increase the concentration of B. More generally, decreasing the concentration of a reactant will cause the equilibrium to shift toward the reactants. Increasing the concentrations of other reactants and decreasing the concentrations of products. The converse is also true, decreasing the concentration of a product will cause the equilibrium to shift toward the products. Increasing the concentrations of other products and decreasing the concentrations of reactants. It is important to keep in mind that Le Chatelier's principle only applies to reversible chemical processes. Chemical equilibria. So everything we have said here does not apply to reactions that can only proceed in the forward direction.
What is a ground state?
Lowest energy state for an atom or molecule.
What are enantiomers?
Enantiomers are molecules that are chiral. In organic chemistry, if a carbon atom is bonded to 4 different atoms, or groups of elements, then we can draw two enantiomers of the molecule. Remember that the connectivity does not change, just the arrangement of the atoms in space. Wait, what do those dashed and wedged bonds mean? Up to this point we've mostly been representing molecules as flat objects, where chemical bonds are just shown as straight lines. But molecules are not flat. In the previous question, the four halogen atoms around the central carbon form a tetrahedron. Chemists use dashed bonds to indicate that they are behind the plane of the paper. And wedged bonds come toward you, above the plane of the paper.
What are some chemical reactions that we can observe with our naked eye?
There are lots of chemical reactions that we can easily detect by sight. Some examples are the formation of rust on metal, wood burning, fireworks exploding, silver becoming tarnished, or baking soda and vinegar reacting with one another.
How does popcorn pop?
The shell of a popcorn kernel is a hard, moisture-resistant coating protecting an interior filled with starch and some water. As the kernel gets hot, the starch inside first softens and then the water turns into steam, which raises the pressure inside the kernel. At some temperature the pressure inside the corn kernel is high enough to rupture the hard shell, and the kernel pops. The hot starch quickly cools, trapping tiny air bubbles inside and making a delicious, solid foam.
What is metallurgy?
Metallurgy is the branch of science that deals with the properties of metals composed of both pure elements and those of mixtures of metallic elements, which are called alloys. It represents one of the first efforts to manipulate and understand how elemental composition of a substance affects its physical properties.
What is a magnetic quantum number?
The third quantum number, m, which describes the direction of the electron's angular momentum.
How does waterproof mascara work?
Like we talked about in the chapters on macroscopic properties and biochemistry. Hydrophobic materials do not dissolve well in water. So it makes sense to make waterproof mascaras from something hydrophobic. Waterproof mascaras contain a combination of waxes to make them resistant to washing off in water.
What is fire?
The chemical description of fire is a combustion reaction. It involves the reaction of oxygen with molecules in some combustible material. The fire itself is caused by energy released by this reaction in the form of heat and light. The fire you see is not only the light that's being released, but also glowing hot gases.
Why did Adolf Friedrich Johann Butenandt, Germany, win the Nobel Prize for Chemistry?
For his work on sex hormones, and Leopold Ruzicka. Croatia, for his work on polymethylenes and higher terp-NS. Butenandt was the first to isolate and crystallize a compound with the characteristics of a male sex hormone by extraction from male urine. Butenandt characterized the chemical formula of this complex, and called it androsterone. It was then discovered that this compound was actually slightly different from testosterone. But Butenandt and Ruzicka were both able to synthesize testosterone from androsterone. Ruzicka synthesized the same compound, androsterone, that Butenandt isolated from male urine. He too was able to convert it into the male sex hormone testosterone. Ruzicka also worked to synthesize and characterize polyterpene complexes that are related to physically and biologically important compounds, including sex hormones. Ruzicka's work contributed greatly to the knowledge surrounding sex hormones, which, of course, are very important physiologically. And his work thus laid the ground for future investigations into the roles of these complexes.
How is O2 transported through the body?
Oxygen enters our body through our lungs in the air we breathe. O2 makes up about 21% of the total volume of air on Earth. From the lungs, O2 diffuses into the bloodstream, where it binds to a molecule called hemoglobin in our red blood cells. The binding affinity of O2 to hemoglobin is pH dependent such that oxygen can readily be picked up by red blood cells near the lungs and then released into tissues and other areas of the body that need it.
What is dry ice, and why does it evaporate from the solid phase?
Dry ice is solid carbon dioxide, CO2. At constant atmospheric pressure we see that an increase in temperature will bring it from the solid phase directly to the gas phase. This process is called sublimation, and it takes place at -78.5 degrees Celsius.
How do photovoltaics convert light into energy?
Photovoltaic cells are the materials responsible for converting the energy in photons of light from the sun into energy that can be stored or used. Individual cells usually range in size from areas of roughly 1 square inch to 1 square foot. And thousands of cells can be used simultaneously to harvest large amounts of energy. When photons of light strike the photovoltaic material, they excite electrons from a piece of silicon that has been treated such that the excited electrons will gather on one side. This creates a potential difference within the photovoltaic cell such that there is now a positive and negative side, similar to a battery. At this point, the photovoltaic cell has now converted some of the energy from the photons into electrical potential energy. This potential difference can be discharged to transfer the energy for immediate use, or to be stored while the photovoltaic cell continues to collect additional photons.
Why did Walter Hermann Nernst, Germany, win the Nobel Prize for Chemistry?
For his work in thermochemistry. Nernst made several somewhat related contributions to chemistry surrounding the specific heats of compounds at very low temperatures. The use of galvanic cells and the ability to calculate chemical affinity from thermochemical properties, and surrounding variations in chemical equilibria at different temperatures. Nernst's most significant gift to chemistry can be stated succinctly by saying that he and his co-workers helped to make possible the calculation of whether a reaction will take place to a significant extent under a set of known conditions. Nernst also was the first to formulate the third law of thermodynamics.